Protection methods are represented as per IEC and CENELAC standards. International Electrotechnical Commission (IEC) has developed the IEC International Standards. This standard has been adopted by 51 countries worldwide. European Committee for Electrotechnical Standardization (CENELEC) has developed CENELAC standards, which have been adopted by 30 European countries. Explosion-proof enclosure XD. This protection method is based on the containment concept. An explosion-proof enclosure or housing can contain an internal explosion within the enclosure without releasing burning or hot gases to the surrounding area, which may be potentially explosive. The explosion-proof equipment must also operate below the recommended maximum surface temperature. This is adopted in hazardous spaces for motors, transformers, actuators, solenoid valves, lamps, switches, and for all parts that may generate sparks. However, high maintenance and calibration costs make the use of this method less cost-effective than that of intrinsic safety. Motors in hazardous areas are of XD standard. Even electrical connections to the motor must be via certified explosion-proof XD glands. An example is the gas compressors used in LNG carriers. Increased safety XE. This protection method is based on the prevention concept. It is suitable for use in zones 1 and 2. Electrical circuits incorporate special measures to reduce the probability of excessive temperatures and the generation of arcs and sparks in normal service. It applies only to electrical equipment where no parts produce arcs or sparks and where the limiting temperatures are not exceeded in normal service. This technique can be used for the protection of terminals, electrical connections, lamp sockets, and squirrel gauge motors, and is often used in combination with other methods of protection. Motors fitted in potentially hazardous areas such as the motor room of an LNG carrier shall also be ideally certified to XE classification since the area is only safe by virtue of the ventilation. The increased safety method of protection is recognized in Europe by the CENELAC standard but is not adopted in the United States or Canada. Intrinsically safe XIA and XIB. Intrinsic safety is the protection method that is most representative of the prevention concept. It is based on the principle of limitation of the electrical energy available in circuits and equipment to a level too low to ignite even the most easily ignitable mixtures in a hazardous area. An intrinsically safe circuit is virtually incapable of generating arcs, sparks, or thermal effects that are able to ignite an explosion of a dangerous mixture, both during normal operation and during specific fault conditions. Intrinsically safe barriers are installed in the circuit to limit current and voltage in the hazardous areas to avoid sparks or hot spots under fault conditions. Example, Zener barriers. This is the only method that protects the apparatus and its relative wiring in hazardous areas, including the breaking, short-circuiting, or accidental grounding of the connecting cable. Also, maintenance and check procedures can be carried out by competent personnel even when the circuit is being powered and the plant is functioning. As per the IEC standards, intrinsically safe devices are classified as XIA, safety maintained with up to 2-component faults. Hazardous area equipment may be used in zones 0, 1, and 2. XIB, safety maintained with up to 1-component fault. Hazardous area equipment may be used in zones 1 and 2. An additional E in front of XIA or XIB, that is EEXIA or EEXIB, means that the equipment complies with unified European standards. Pressurized. This protection method is based on the prevention concept. In this type, the electrical equipment is housed in a suitable container, which is pressurized with air or inert gas from a safe source. This ensures that any flammable vapor in the surrounding area is prevented from entering the box. Such protection will only be acceptable when used in conjunction with shutdowns in the event of loss of pressure, etc. Purged type protection is used in enclosed areas which contain no source of hazard but is located within a hazardous area. Mechanical ventilation is used to provide protection. The use of positive pressure ventilation together with suitable alarms, etc. may allow the room to be considered as safe, thus allowing the use of non-certified equipment. An example is the motor room on an LNG carrier.